our presentation is titled Automation and Employment, the Cause and Effect of Modern Trends in Technology. We've noticed that recently in the media there's been a notable trend in concern about the advances of technology and its effect on the employment market. We noticed that there are certain skilled professions that are going to become obsolete and outdated with recent advances in technology, and we want to know what's going to happen to people that fall into these categories of having skilled jobs that are going to be replaced by technology. In history, we've seen several industrial revolutions, the first one starting in 1760, ending in 1840, where we saw the introduction of mechanical production using hydroelectric and steam-powered equipment. There was another industrial revolution in 1870 that ended in 1914 that involved the introduction of mass production of specialized goods using electricity. And then in the early 1970s, late to late 1990s, we saw automation of production in electronics and IT. Then in the early 2000s to now, we're seeing a trend in changes with networking and the exchange of information between humans and machines.
Our data looks at 3 separate countries: Germany, the United Kingdom, and the United States. Each dataset focuses on that country's technology, employment rate, annual wages, productivity, profit, and hourly wages for 3 of the 4 different phases of the Industrial Revolution. Our data is a combination of 7 different datasets we found online. In order to get our data to work properly, we had to clean the data, including normalizing the info and getting the data into correct intervals.
To determine causal relationships in our data sets, we calculate the average treatment effects of different variables on each other, which is essentially the difference of 2 interventions on a variable. So to actually find these relationships in our graph, we consider every possible pair of nodes in our data and calculate the average treatment effect for each of them, considering one node the parent and the other the child. Then if the average treatment effect that was calculated is greater than some threshold and the reverse relationship of the nodes is not already in our edges, then we simply append that pair of nodes to our edges. When looking at the causal model for Germany from 1840 to 1879, we can see that technology has a causal relationship with employment, wage, productivity, and corporate profits. However, when we look at the graphs, we see that as technology advances, employment, wages, productivity, and profits also all go up. Therefore, we can conclude that our initial hypothesis that technology negatively impacts employment and wages is not true for the first phase of the Industrial Revolution.
For the United Kingdom, our data begins during the second phase of the Industrial Revolution in 1890 and ends just recently in 2017. During this time frame, we identified a major difference to Germany. Employment goes from being dependent on year-end technology to becoming directly dependent on all other factors. Technology, productivity, and wages all saw a consistent increase, while annual wages saw a steady drop.
When examining the data sets regarding the United States from 1987 to 2017, we can see from our causal model that technology has a direct effect on profit, productivity, employment, and wages. We can see from our graphs that as there's a sharp increase in technological advance, there is a decrease in the amount of hours being paid for by companies. So as productivity increases with less people, wages also increase, but there's still a lot more profit to be made because less people are being paid.
And here's a link to all of our datasets.